In this lesson, we will examine the issues of operational control of air transportation flights in terms of responsibilities and procedures. The operator is, of course, ultimately responsible, although we saw that he can delegate operational responsibility to an accountable manager. Basically, however, the operator must operate in an approved manner and within the terms of his AOC. To this end, he must establish and maintain a method of exercising operational control over all aeroplanes operating under that AOC. For airlines, the classic method is well known. That is, an operations room is staffed by experts in operational control. These experts, called either operations officers or flight dispatchers, work with the pilot in command to create a safe and sensible plan for conducting a particular flight. This plan will take account of all of the variables and most of the contingencies that may affect the flight. The particular procedures for operational control are documented in an operations manual, more commonly referred to as the Ops Manual. The Ops Manual is an important area of study, and so will be dealt with in its own lesson later. Suffice it to say, however, that it will contain, as quoted from EU Ops, procedures and instructions for each aeroplane type containing ground staff and crew members' duties for all types of operation on the ground and in flight. We have already referred to the operations personnel as experts, and experts they must be. EU Ops requires the operator to ensure that all personnel involved in ground and flight operations are properly instructed, have demonstrated their abilities, and are aware not only of their responsibilities, but also the relationship of their duties to the operation as a whole. Our next topic examines the operator's responsibilities towards the safe and efficient conduct of each flight. Before we study this area in detail, here are some required terms and their definitions. First, those concerning aerodromes. And secondly, the remainder of the required terminology, much of which relates to ETOPS, extended range operations, for two-engine aeroplanes. The operator is required to produce checklists for the crew to cover the three flight situations: normal, abnormal, and emergency operations. These checklists will encompass actions derived from the procedures laid down in the Ops Manual and the source document, the Aeroplane Flight Manual, AFM. During the critical phases of flight, the operator must ensure the procedures require the crew to complete only those actions necessary for safe flight. Many airlines operate a sterile cockpit below 10,000 feet, such that only those issues pertinent to the operation may be discussed and dealt with. The next two articles concern air traffic services, ATS. First, if they are available, use them. The second article is more technical. If in flight changes need to be made to the air traffic flight plan, they should be cleared through air traffic services first, before onward transmission to the crew. For example, if the operator requires the flight to make an unscheduled stop at an en route airport to pick up a package, airline operations should check with ATS to ensure the diversion can be facilitated. If so, then, and only then, should the change in instructions be transmitted to the crew. For this purpose and others, many operation rooms have direct telephone link-ups with their local area control centres. The following three articles deal with airport usage, or more technically, aerodrome usage. The first issue is adequacy. In other words, the aerodrome must be able to support the type of aeroplane and the type of operation. Obviously, with commercial air transportation, we need not only adequate runways, taxiways and navigation, communication and surveillance aids, but also appropriate ground handling and terminal facilities. Having identified adequate aerodromes, the operator must then specify the operating minima for their use, especially in terms of minimum visibility requirements. These minima must then be approved. The minima will be specified in the Ops Manual, which, as you may imagine, must also be approved. More on this later. If the authority is not satisfied with the operator's minima, it will usually add an increment, and this new increased minimum must then be used. Along with minima, the operator must consider noise abatement. Although with the introduction of modern high-bypass turbofan engines and hush kits, airport noise nuisance is not what it used to be, the requirement to operate, especially during departure, as noiselessly as possible, is still a high priority. Noise abatement must never supersede safety, of course, but within the limitations of simple, safe operations, an operator is required to construct two noise abatement departure procedures, NADP 1 and 2. NADP 1 is constructed to reduce noise over close-in problem areas, while NADP 2 is for problem areas that are more distant. In the case of commercial air transport operations, these aerodrome operating minima, AOM, will normally be associated with instrument departures and approaches. The Air Law CD-ROM in this ATPL series examines instrument procedures in great detail. As far as this lesson is concerned, the emphasis is on their use. Standard instrument departures and approach procedures, that is, those published by the state, should, in normal circumstances, be used. Deviations from the standard are permitted, but only if minima are not infringed, especially obstacle clearance minima. In all cases, however, the final approach must be flown either visually or in accordance with the standard procedure. Finally, here are the components of the required system to use the minima for a particular approach and landing procedure. Having dealt with the operator's responsibilities with respect to the use of aerodromes, we will, in this section, turn to his responsibilities regarding the routes to be flown. There are a number of basic requirements that must be met, and we will end this section with them. However, the overriding requirement is that the operator must ensure that operations are conducted in accordance with any restriction on the routes or the areas of operation imposed by the authority. At this juncture, let us examine the particular requirements for specific airspace. First, RVSM, that is, airspace with reduced vertical separation minima. Here, authority approval is required, which will involve meeting the equipment and training demands of this airspace. And second, airspace with specified navigation performance requirements. Again, authority approval is required, especially regarding meeting the navigation performance demands of the airspace. Additionally, if the airspace has contingency procedures, these procedures must appear in the operator's Ops Manual. The North Atlantic, as we shall discover, has both RVSM and navigation performance specifications. Here are the basic requirements for the routes the operator wishes to fly. Continuing our study of the operator's responsibilities with respect to routes of flight, we now move on to the topic of remote area flights by twin-engined aeroplanes. We will examine this topic both in terms of, quote, normal operations and ETOPS, extended range operations, in two-engined aeroplanes. Although EU OPS provides the requirements for all aeroplanes, we will confine our studies to airliners, both larger and smaller. Our interest lies with those aeroplanes designated Performance Class A. They are divided, for the purposes of this article, into those of maximum takeoff mass less than 45,360 kilograms, with a maximum approved passenger seating configuration of 19 or less, and those which exceed either of these limitations. In this section, we will call the first group smaller airliners and the second group larger airliners. First, we will examine normal operations, that is, non-ETOPS. The operator must not operate further from an adequate aerodrome, under standard conditions in still air, than the distance that would be flown in a specific time at the one engine in operative cruise speed. For larger airliners, that time is 60 minutes. For smaller airliners, the time doubles to 120 minutes. Or, for smaller turbojet airliners, and if approved by the authority, may triple, that is, up to 180 minutes. This information, including the one-engine operative cruise speed, must, of course, be included in the ops manual. Now we will turn our attention to ETOPS. In order to conduct these operations, which are generally for larger airliners to operate beyond the 60-minute limitation, the operator must have authority approval. Additionally, before conducting an ETOPS flight, the operator must ensure an adequate ETOPS en route alternate is available. This concludes our discussion of overwater flights in two-engine airliners. We will be revisiting ETOPS in the lesson on long-range flights later on. Before we turn our attention to minimum flight altitudes, MFA, here, for completeness, are the limitations for Class B and C aeroplanes. Terrain and obstacle clearance is of course vital to any operation. Therefore it should be of no surprise that the operator has responsibilities in this area. The operator is required to establish minimum flight altitudes using an authority-approved method. If the governing state has set a higher MFA, this higher figure must be used. When determining the MFA, the operator must consider a number of factors, including the limitations of the altimeter, particularly in terms of pressure and temperature, ATS requirements, and any foreseeable contingencies. Here are the major factors for consideration. Our last topic for this lesson deals with fuel policies, plans and procedures. If you are planning a car journey and want to ensure you have enough fuel for the trip, but no more, you can probably imagine all of the things that might delay you, such that you would want to carry additional fuel to overcome these problems. Fuel planning in an aeroplane is much the same. You want to have enough fuel to reach your destination, but not over much, or you will burn expensive fuel just carrying that extra weight. You also want, however, additional fuel above the minimum, just in case flight conditions are not as you anticipated, or some problem necessitates a change of plan. When constructing the fuel plan, the most appropriate data should be used. That is, the correct fuel burn rates for particular aircraft masses under the relevant meteorological, navigational and operational conditions. Here are the EU OPS requirements for fuel carriage. You should note that the final total fuel figure is at the prerogative of the pilot in command. If any in-flight replanning is required, the elements of the final fuel figure are similar. There will be no requirement for taxi fuel, of course, and the trip fuel will be only that required for the remainder of the proposed flight. Appendix 1 to this article, OPS 1.255, details the requirements for each of the segments of the total fuel requirement: trip fuel, alternate fuel, etc. Whilst this is not a requirement for the Operational Procedures syllabus, it is important, and is therefore a subject for the flight planning syllabus. Our last subtopic is refueling and defueling. Some aviation fuels are relatively volatile, therefore special rules and procedures for their use exist. It is the operator's responsibility to establish procedures for refueling or defueling with wide-cut fuels, for example Jet B. Additionally, the operator must ensure that when using this type of fuel or avgas, no passengers are around, neither aboard, embarking, nor disembarking. For other types of aviation fuel, it is permitted to refuel or defuel with passengers in the vicinity. However, all precautions must be taken to ensure their safety, including stationing qualified personnel aboard, usually cabin crew, to direct any evacuation if needed. Finally, to remind you, here again are the fuel policy requirements. This ends our examination of the EU OPS regulations for the operator's responsibilities regarding operational control.